Okay, we're still looking at question 2, free response 4 assignment, and we need to look at C and D on question 2. And this is going to take a little bit of explanation because I want to make sure you understand what Nash equilibrium is. So we're looking at figuring out where we would be here in the matrix if we reached what is termed a Nash equilibrium. So let's jump back over here and let's take all these guys out of the way, and we're going to look at each one of these, okay? And we're going to figure out, let me bring this guy back down here where he belongs because we're going to use him in a minute over here. But let's move this up and let's just think about what do we mean when we say Nash equilibrium. That's going to be a place on this matrix where neither pie crust or la pizza is going to want to change because changing would make them worse off. Okay, we put a period right here. Now, the important part here, well, one of the important parts here is that we clarify that each of these players know the strategies of the other. So each of these players know what the matrix is for both themselves and the other restaurant. And that's also stated in the problem right here, right? Both firms have complete information. If that's not true, then you really can't arrive at a Nash equilibrium. So let's jump back over to our problem. So now we're going to look at each of these and think about each one, okay? And we're going to work our way around because Nash equilibrium is going to be either here or here or here or here, or not at all. So let's see. Now, if we're here, if we're in the, I guess we'll call this quadrant, what? I don't know, 1, 2, 3, 4. You know, this is a quadrant where pizza and pie crust both choose to advertise. Now, the way you want to think about this is if from the standpoint of La Pizza, if they know that pie crust is going to advertise, so which pie crust is going to be here, right? So the choices that La Pizza has, if they know that pie crust is going to advertise here, then La Pizza can either advertise or not, right? So if they moved, they would be better off, right? They would be better off. So that tells us right away that this is not a Nash equilibrium, because a Nash equilibrium is a situation where no player has anything to gain by changing its own strategy, right? So if we look at if we only looked at this from the perspective of pie crust, if they change, because their choice is if La Pizza advertises, then their choice is either to advertise or not. Now they would be worse off if they moved, right? So from their same point, it would hold true. The requirement for a Nash equilibrium would hold true, but since it doesn't hold true for both, since it does not hold true for La Pizza, who would be better off if they changed, then we know this isn't it. Okay, this is not a Nash equilibrium. Now let's move down to here and see what would happen here. If we start off with looking at it from the perspective of La Pizza, if they change, they're going to be worse off, right? So they want to stay right where they are. So far, this looks like it could be a Nash equilibrium. Now, but what if pie crust changes from not advertising to advertising? They're actually going to be better off, right? So they would be motivated to change out. So if you think about it like this, if pie crust knows La Pizza is going to advertise, then they're going to change from here and they're going to jump up to here. Okay, so they're not going to want to stay. So this is not, this quadrant right here just does not qualify as a Nash equilibrium either. Okay, now let's move over to here and see what's going to happen over here. Okay, so as once again, if we look at it from the perspective of La Pizza, they can either be here or they can be here. Okay, if they know that pie crust is not going to advertise, so they would be motivated to change, right? Because 500 is better than the 400, so they're not at a Nash equilibrium right here because they would want to move, right, to get more, a profit. Now, from the perspective of pie crust, they would want to move as well up to here, right? Because if they know that La Pizza is going to not advertise, then they're going to want to be not here, but here, okay? So that doesn't work. This one doesn't work at all. Now, lastly, let's look at the quadrant where La Pizza decides not to advertise and pie crust decides to advertise, right? So the choices, if we look at it once again from the perspective of La Pizza, and they assume or know that pie crust is going to advertise, then they have a choice of either being where they are or moving over to here, which is worse. So they're going to stay. They're going to stay right here. Now, from the perspective of pie crust, if they know that La Pizza is not going to advertise, then they can either be here where they are or they could move down and not advertise down here, which would make them worse off, so they would stay as well. So both parties, both restaurants would be worse off if they moved, so they don't have anything to gain by moving, so they stay where they are. So we can say that this quadrant right here is where the Nash equilibrium is, where La Pizza does not advertise and pie crust does, okay? And the profits are 450 for pie crust and 300 for La Pizza, and that's your answer. Kind of a long answer, but I mean, I think it's very important for you to really have a clear understanding of what we mean by Nash equilibrium. And it may not, you may see a matrix where it's not there at all, or it's there in more than one quadrant. In this case, this is the only quadrant where we have a Nash equilibrium. Okay, let's finish this up. This last part is kind of easy, I think. They're asking us to suppose that advertising costs increase by $60 a day. Redraw the matrix to reflect the effect of the higher cost in advertising. Okay, well, we know that we're not going to change. Let's jump down here. Any of the profits that they get from not advertising, because that's not going to change at all, because the only thing that's happened here is the price of advertising has gone up by 60. So this amount right here, where pie crust does not advertise, here and here doesn't change at all. Where they both advertise, that's going to change. Where pie crust advertises right here, that's going to change. Where they both don't advertise, that's not going to change at all. And where La Pizza does not advertise, that's not going to change it at all either. So the only ones that are going to change are the ones that I've got shaded, and they're going to all go up by 60. So 250 is going to, drop. Sorry, I said it backward. Are going to drop. Their actual profit is going to decrease because of the cost of advertising has gone up. So that means that these numbers here, these dollar amounts here, which are profit, they're going to go down by 60. Okay, let me extend this so we can center this up. Okay, so 250 minus 60 is 190. So that's going to go right there. Okay. So I'm redrawing the matrix. 200 is going to drop to 140 because it drops by a 60. So that's going to go right there. 500 is going to drop to 440. So that goes right there. And it should be, let me just try something here if it's going to work. Nope, that didn't work. Do that anyway. It's 440. I think if I go here, I think this is going to work. Just trying to make this prettier. Let's see. Order, bring the front. Okay, there we go. That's going to go there, and then the last one up here that's going to change is 450 minus 60 is 390. I'm going to do the same thing again. Order, bring the front. There we go. So this should look nice like that, right? Okay. So that's what your redrawn matrix should look like. Once again, you're not going to want to change any of the profits that they're going to enjoy if they don't advertise, because that doesn't change, since the change here is an increase in cost of advertising of $60, which is going to lower their profits by 60 everywhere that they are advertising. And I believe that takes care of question 2. And when we come back, we'll look at question 3.